Modern construction is defined by its moving parts. A single commercial project shatters into hundreds of separate contracts, spanning isolated design phases, fragmented procurement chains, and rotating site crews. This fragmentation creates informational blind spots. A decision made by a client regarding budget, or a line drawn by an architect in a studio, can multiply into severe physical hazards months later when workers are actually standing on site. The Construction, Design, and Management Regulations of 2015, known as CDM 2015, serve as a legal architecture designed to bind these disconnected phases together. The central mechanism of CDM 2015 is direct alignment. It forces health and safety accountability to sit exactly where the project control and funding reside. By doing this, the regulations transform a chaotic supply chain into a unified liability structure, making sure that the people who create the risk are legally obligated to manage it. Before looking at who carries these duties, we must establish exactly how the law weighs them. UK safety law applies different levels of obligation depending on the severity of the hazard. At the highest level are absolute duties. These are written with the words must or shall. They are non-negotiable legal mandates that a duty holder has to execute without exception. Below absolute duties are qualified duties, most notably the legal standard of so far as is reasonably practicable, or SFARP. This scale balances a high-severity hazard against the financial cost, time, and logistical trouble to mitigate it. The law requires mitigation even if the cost slightly outweighs the risk. You can only refuse if the cost is grossly disproportionate to the actual danger. Understanding this threshold is crucial. It prevents regulators from demanding impossible safety standards, while legally barring companies from using budget constraints as an excuse for negligence. This timeline represents the lifespan of a construction project, from concept to final handover. The foundation of this entire structure is the client. Because the client holds ultimate contractual and funding control, they carry the baseline legal accountability for the entire project. They must make suitable management arrangements and ensure sufficient time and resources are allocated to execute the work safely. To start the process, the client has a critical duty to generate pre-construction information, or PCI. This includes providing existing site surveys, asbestos records, and ground condition reports. Then we reach a pivotal legal trigger, the moment it becomes foreseeable that more than one contractor will operate on the project at any time. Crossing this threshold mandates action. The client must formally appoint a principal designer and a principal contractor in writing as soon as practicable. If a commercial client fails to make these appointments, massive legal liabilities for upstream design and downstream site execution default entirely back onto the client. This diagram shows the role tasked with controlling the earliest phases. The principal designer occupies the pre-construction phase, bridging the gap between the client's initial concept and the start of physical work. The principal designer must coordinate with all other designers to engineer safety into the project before physical construction begins. To do this, they operate under a primary framework known as the General Principles of Prevention, actively avoiding risks where possible, evaluating the risks that are unavoidable, and putting in place proportionate measures to control hazards at their source. For example, if a building requires air conditioning, the principal designer could specify ground-level HVAC units instead of roof-mounted ones. This permanently eliminates future work-at-height hazards for maintenance crews. The principal designer's ultimate value is eliminating hazards on paper, ensuring they never manifest as physical dangers on a live site. Next, we introduce the execution engine, the principal contractor. This role takes control the moment the physical build begins. The principal contractor is responsible for coordinating the implementation of all applicable health and safety laws on site, organizing cooperation between multiple subcontractors, and enforcing site rules. They hold absolute duties regarding the physical boundaries. They must take the necessary steps to prevent access by unauthorized persons. They are also required to provide suitable site inductions and ensure specific welfare facilities, outlined in Schedule 2 of the regulations, are operational throughout the construction phase. Crucially, regulations require the principal contractor to actively consult and engage with the workers on site. These are the individuals directly exposed to the risks, and their feedback is a mandated part of site management. The principal contractor serves as a legal firewall, ensuring that careful upstream risk planning actually survives the complex reality of daily operations. This flowchart illustrates the continuous three-part data pipeline that acts as the operational engine of CDM 2015. First, the client and principal designer collate the pre-construction information. This feeds raw, existing site hazard data into the system. Second, the principal contractor is legally required to translate that PCI into the construction phase plan. This must happen before a single site boundary is established or any digging begins. Finally, the principal designer curates the ongoing design data and site modifications into the health and safety file. At the end of the project, this finalized file is handed back to the client. It dictates safe practices for anyone conducting future maintenance, cleaning, or demolition on the structure. Severing a link in this data chain means crucial information is lost. This is the primary root cause of fatal physical failures on construction sites. To see how this regulatory timeline translates into severe, real-world consequences, we look at the Part 4 site requirements. Consider deep trench excavation, consistently ranked as one of the highest risk operations in civil engineering. An unsupported ground failure happens with catastrophic speed and weight. A single cubic meter of soil can weigh over 1.5 tons. No ground can be relied upon to stand unsupported. In this scenario, the two primary mechanisms of fatality are asphyxiation from a trench collapse and electrocution from striking live underground utilities. When a trench collapses, it is rarely an unforeseeable accident. It is almost always a predictable physical manifestation of a broken CDM matrix upstream. This diagram shows a fully compliant, highly complex excavation site. By freezing time, we can perform a legal deconstruction and trace each physical element back to its origin. The hazard of utility strikes is mitigated here because the client fulfilled their absolute duty to provide accurate underground service mapping within the initial pre-construction information. The hazard of water inflow and soil collapse is managed because the designer assessed the soil permeability early on, mandating safe battering angles and specific dewatering techniques. Surcharge loading, extra weight pushing on the trench walls, is avoided because the principal contractor established clear traffic routes via the construction phase plan, keeping heavy plant vehicles away from the excavation edge. And the physical trench boxes are present because the principal contractor ensured that temporary support equipment was physically on site before any digging began. The resulting safe physical environment is the direct consequence of flawless data transfer across the CDM duty holder matrix. Even with flawless planning, the physical site must be monitored. Part 4 rules mandate a final verification loop to maintain the integrity of the excavation over time. The law strictly requires that a competent person physically inspect the excavation supports at the start of every single working shift. Work cannot proceed until it is confirmed safe. Furthermore, an immediate reinspection is mandated after any event that could compromise stability, such as an unexpected rockfall, damage to a support, or heavy rainfall. These physical checks must be supported by a formal written report to document exact legal compliance. If a failure does occur, safety investigators will pull this specific chain of documentation. They will trace the physical collapse back up the matrix to find the exact duty holder who broke the system architecture. CDM 2015 is ultimately a unified chain of custody for human life. It demands that accountability is engineered into a project's DNA, from the earliest conceptual sketches to the final day of construction.